Line there highlighted in blue is the report we're going to be sharing key findings from today. It's our Hyperscaler Digital Ecosystem Market Landscape Report. We also have reports on a variety of topical and individual vendor and operators spanning private networks, 5G, and edge computing. And then we cover a variety of tier one operators, vendors, and hyperscalers on an individual report basis. So I do want to set the stage and recap the prior webinar, and then we're going to jump into this part two. So hyperscalers are reimagining how networks are built, owned, and operated. This was the title of the prior webinar. Basically, that webinar focused on how hyperscalers are building their networks. They are all building global networks. This webinar is going to look at the business model. Why are they spending billions of dollars building out networks globally? What is the justification for that investment? And what is the business model that they are intending to use and that is already in use in various ways? So the key takeaways from that webinar are that hyperscalers, and specifically we're talking about Amazon, Microsoft, Alphabet, Apple, Meta, and Rakuten. We're talking about 6 companies here. They already own and operate the largest networks in the world. They have the most extensive backbones, and they also have the device ecosystem, the vast majority of the device ecosystem. If we think about the iOS and Android ecosystems, just those two, you can start to think about scale and pervasiveness of those ecosystems. The next phase that they're looking at building out networks is the edge and the access layer. They're employing multiple approaches for the access layer, just given the cost associated with it. The access layer of the network is arguably the most expensive part of the network to build, and because of that, they're looking at multiple approaches to defray the cost and basically to get what they need out of it. They do not want to become telecom operators. That is not the objective here. The network, though, is of critical importance for their business, which is predicated on data and driving outcomes from data, and that manifests itself across their digital businesses, such as financial services, digital advertising, and e-commerce, those types of things. And to reiterate, hyperscalers are in the data business. Providing connectivity is a cost of doing business, and it's a means to driving the data business forward. So we're going to jump into the business case for network ownership. This is the very high level how we think about this disruption. There is a convergence of distributed computing, which is on-device computing, on-premise computing, edge computing, and central cloud. So basically, wherever there's compute taking place, the interweaving of those different environments creates a distributed computing framework. And when you blend that with intelligent connectivity, which is the mobile core, just overall the connectivity layer, you can generate alpha from that. You can generate new use cases, and you can create economic value. Hyperscalers are directly center of this convergence. This is exactly what they are doing. They are leveraging their distributed computing infrastructure and other assets, and they are moving very aggressively into the intelligent connectivity domain. And by doing so, there's going to be trillions of dollars in economic value created by the convergence of these technologies. So when we think about 5G, edge computing, AI, blockchain, all of those fancy new technologies that everybody likes to talk about, we do firmly believe there will be trillions of dollars in new economic value created from these technologies. The big question is, who is going to capture the majority of that value? And based on what we're seeing and where companies are heading from a strategic standpoint, the hyperscalers are going to be among the most benefited entities of this convergence. Hyperscalers view distributed computing and intelligent connectivity as tightly integrated concepts, and they want to control that entire stack. So why own and operate networks? So there's a few reasons. One is you get greater control over data and the end user relationship. So basically, you have more control over the customer and what the customer is doing. You get access to new types of data, like location data, subscriber data, device data, visibility into network performance and user experience. These are critical things to consider when we think about new use cases for the network, including but not limited to the metaverse and things like autonomous transportation, connected vehicles, things of that nature. Service level agreements and QoS, ensuring that customers have a certain level of quality while consuming hyperscaler platforms. This is very important. Making sure the quality of experience is there. Managing that, controlling that experience is very important if a hyperscaler is selling a premium offering. Data ownership. Who owns the data? This is very important. Telcos have vast data lakes on subscriber information and data that comes from the network. That is incredibly valuable, potentially very valuable information that can be leveraged for driving new business models. The problem is that those entities have not been very good at monetizing the data that they have. Hyperscalers are adept at monetizing and leveraging data at very large scale. Having the network drives and supports use cases hyperscalers are focused on. We're going to talk about some of those particular use cases. And it drives new business models. We're going to talk about that new business model. And then, of course, there's the security angle, making sure that the system is secure. Not that current systems aren't secure, but when we think about how networks are evolving, the architecture is evolving, how openness is coming into the picture, there's new vectors for new threat vectors, and owning more of the stack, controlling more of that environment, potentially could be a more secure way of handling data. So we're going to talk about use cases, and basically these are some examples of use cases that hyperscalers are fixated on. Like, this is like top priority stuff. The problem is, in order for them to realize these use cases at scale, they will need to own networks, and they will need to tightly integrate those networks into their cloud infrastructure. And that's exactly what they're doing today. And I'll give you guys like tangible examples of like how this is actually happening, portending much greater disruption as we go forward. On autonomous transportation, there's two ways to think about it. There's for businesses and there's for consumers. For businesses, Amazon is very keen to leverage drone technology with 5G to do drone package delivery. 86% of Amazon packages weigh 5 pounds or less. And if you think about the payload for a drone, 5 pounds is a sweet spot. So if you start to think about the $80 billion or so that Amazon is on track to spend this year shipping packages, if they could leverage drones for even a small portion of that, you could start to think about significant cost savings, like on the order of billions of dollars. That magnitude of cost savings would justify investment in large-scale network infrastructure. You also have Waymo. That's the Google autonomous platform. They have something called Wing, which is Google's version of basically drone package delivery, something that they're pitching to logistics companies. In order for Google to guarantee QoS and SLAs as part of that, they will have to control more of that network. relying on a network of partners to manage SLAs and customer expectations in real time autonomously, it really is going to be extremely challenging to do that. It's much easier if they can control more of the infrastructure stack. On the consumer side, it's about time spent in ecosystems. So the less time people have to drive and commute and do things of that nature, the more time they have to be on their phone or in the screens that are built into the dashboard of the vehicle. That means more ecosystem time, which means more advertisements can be sold and more other types of services can be sold inside of the hyperscalers ecosystem. This is something that Apple's looking at for as they think about Apple Car, and this is something that Microsoft is also keen on with their work they're doing with GM on the Cruise initiative. So we talked about drone package delivery. It's about optimization. It's about leveraging robotics and supercomputing to free up time that can be reallocated to other things, and that can drive revenue directly and indirectly for the hyperscalers. When we think about advertising, which is the primary business of Alphabet and Meta in particular, and a growing portion of revenue for Amazon and Apple and Microsoft, if we think about the evolution of digital advertising, we call it hyper-localized and spatially aware and contextualized advertising. So basically, having a 360-degree view of the end user, you can sell, theoretically, you could sell advertisements that are far higher margin because the targeting is so much better than traditional methods of doing that. You could have, for example, if you're walking down a Whole Foods store, your phone might be pushing you, or the wagon might be pushing you advertisements depending on where you are in the aisle and where you're looking at in a shelf, from a shelf perspective. There might be a time window there to push a coupon to that person from a digital screen that they can then maybe consider buying one product over another one. You could start to imagine the use cases for that. You would need a network that is orchestrating that use case in real time. Those are the types of things that the hyperscalers are fixated on. And the revenue potential of that is very, very large, tens of billions of dollars in addressable market that could be available by the end of this decade from those more advanced digital advertising methodologies. Internet access. This is something that is direct competition with telco, where the hyperscaler is providing low-cost connectivity to underserved or unserved people. And as part of doing that, providing that subsidy, they're monetizing data indirectly. Google does this with the fiber program. Amazon is highly likely to do this with Project Kuiper. They have made public comments that they will be providing high-speed internet directly to end users, to consumers, which is essentially what telcos do for fixed access and FWA today, except Amazon would be using satellite technology. And then Rakuten Mobile, of course, is another excellent example of this, where they have deployed a nationwide network across Japan using a new architecture that is significantly lower cost than a traditional network, CapEx and OpEx standpoint, to run and operate that thing. And the objective is to monetize the subscribers used inside of Rakuten's digital ecosystem in Japan. And by doing that, they can offer subsidized connectivity and they can monetize indirectly, and the customer gets the lower cost of getting internet access, and the monetization model is indirect. And then last but not least, there's the metaverse, which has very significant potential. I would argue trillions of dollars in economic value will just be created by the metaverse by the end of next decade. If we think about the broad range of enterprise and consumer use cases that are available there, it's quite significant. It's early days, but the monetization models will be digital goods, subscription services for things like gaming, and of course there will be plenty of advertising. Meta has basically is betting the future of the company on the metaverse. All of the other hyperscalers are working on the metaverse in some way. All of them are doing this. And they're spending billions of dollars, each one of them, on R&D and on platforms and infrastructure that will help them make this metaverse concept a reality at scale. So there is a justification. There is significant money that will be, and value that will be enabled by these technology convergence. And let's talk a little bit about the business model. How do you actually extract the value from these things? So I want to go back in history first, and I want to look at how we got to this point, because the telecom industry has already fundamentally changed in the last 20 years. We're going to start with the 2G cycle, so the 1990s to the 2000s. 2000. The dominant device type was feature phones. The primary model of monetization was charging for voice minutes and text messages. And the dominant players were telcos. When we went to the 3G cycle, it transitioned to smartphones. So we had the iPhone came out in 2007. We had BlackBerry before that. But the monetization model was less about voice and text, which those prices plunged. It was more about charging for data, per megabyte, per gigabyte. So the industry already changed from voice and text to data between the 2G and 3G cycle. When we went to the 4G cycle, things changed again. We went to full smartphone. Everything is smartphones now, and except for portions of the developing markets where feature phones were still prominent there. But smartphones were taking over the world in the last decade. Data started to go unlimited. We have telcos offering all-you-can-eat data packages. Minutes and text went free. It became free. It went OTT. Think about platforms like WhatsApp, or iMessage, where you no longer need to pay for voice and text. We also had the rise of the digital package and digital ecosystem. So the example I like to use is T-Mobile offers streaming services as part of being a subscriber. So Netflix on us, Apple TV on us, Verizon offers Disney Plus and some other streaming platforms. The point is it's not just about connectivity anymore. It's about what else do I get? What's the value I'm getting from the package, from my subscription? That was where we saw an inflection point, was the last decade, where OTT started to eat into telco in such a way where the balance of power began shifting, and telcos started to lose their control over their own industry. And the value, there was significant value that came during the LTE cycle, which was that 4G cycle. The value, though, the vast majority of that value accrued to the OTT players, and the telcos wound up carrying the burden of infrastructure development, paying for the spectrum, doing all of that, and their revenues were stagnant at a aggregate level. The 5G era, which we're in now, and we see extending through the end of this decade, is going to lead to another step change. Except in this one, it's not just about phones. It's about everything that's connected. And data is going to become unencumbered, which means that the friction of using data is going to go away, where credentialing is going to become more effortless, moving between networks will become more effortless, selling metered data services is going to go away. It's going to be a thing of the past. And we're going to see connectivity increasingly move towards free, and the value, the revenue is going to be generated from what comes over the pipe. Now, the OTT showed us this in the 4G cycle, but in the 5G cycle, it's going to be far greater in magnitude how this actually plays out. And enterprises on the B2B side, it's going to be paying for outcomes. So how much productivity enhancement did I get from this private network implementation or this network slice that I purchased? Or how much money am I saving by implementing this network solution or this solution that has networking as a component of it, but networking and connectivity is not the front and center part of the value proposition. It's a different sale, and it's fundamentally different from how telcos are set up to sell. This model is going to see a break from telco, and this is already in motion. The break is going to be away from telco, and it's going to be toward hyperscale. So if we look at the cloud and how the clouds are created today with the marketplaces and the ecosystems that they've built, cloud resources are consumed in an as-a-service model. It's autonomous, and it is the infrastructure sitting behind that is completely in a new architecture that is fundamentally more cost-effective, energy efficient, easier to use than the traditional way of architecting network infrastructure. We are seeing the balance of power clearly shifting away from traditional players towards the new players being the hyperscalers. We're also going to see the digital service providers, telcos that are making that jump, and we're going to talk about one of them coming up because there's not that many of them, that is doing a really good job making this transition and is going to be a key player in this transformed industry. So we're going to look at the business model a little differently now. We're going to look at the model comparison. So what we have here is the traditional model and the new model. In the traditional model, which is used by telcos and cablecos today, they sell connectivity, which essentially is access to the pipe. They monetize the access by selling units of consumption. So it could be voice minutes, could be data, or it could be wrapped into a monthly subscription plan, either prepaid or postpaid. The end user is typically monetized through directly through metering. And there is an incentive to throttle cap or impede data usage to protect margins, because the more data that's being consumed, there's more energy used in the network, there's more support that's required in the network, more instantiation, more infrastructure required. There is an incentive actually to limit those things, to balance them in such a way where margins can be protected. They provide connectivity only where there's clear ROI. There's still a few billion people in the world that are underserved or unconnected, over 3 billion people to be exact around the world. And that's because the economic justification is not there under the traditional telecom model to support that infrastructure development. The telcos have to buy licensed spectrum. They spend billions of dollars to do so. The end user primarily owns the data, and the telcos market their services for network coverage and quality. So that's the way things have been for decades. It's been that way. It's changing, and it's radically changing. The new business model, which this is what the hyperscalers do, is you leverage the data to sell outcomes, which could include giving away connectivity at cost or for free to drive the data, to drive that data flywheel. And the end user is primarily monetized indirectly through the data generated. So through mechanisms such as digital advertising, as an example. There is an encouragement and an incentive for the hyperscalers to give away as much data as possible, as much connectivity as possible, with no caps, no throttling, nothing. Because the more usage there is, the more revenue and higher margins there is. This is a scale game. The intention is to provide connectivity everywhere and to make it unlimited and to make it effortless, reduce the friction of accessing networks. And the hyperscalers are using free or low-cost, unlicensed, and or shared spectrum to do this. So CBRS, 6 gigahertz, 60 gigahertz, 2.4, 5 gigahertz. Those types of bands, 900 megahertz is being used. The KA bands, the KU bands, those are all spectrum bands that the hyperscalers are using today for the networks that they are building. It's a platform service that they're selling, and they're marketing the outcome. They're marketing optimization of time. They're marketing seamlessness, user-friendliness. When you're in their ecosystem, if everything works effortlessly together, there's an incentive to utilize more of that ecosystem. So I want to look at this a little differently. Basically what we just showed, but now in a diagram. So monetizing the consumer is the traditional model. You sell access to the user. It's a data bucket, usually metered or unlimited, or it's under a prepaid, postpaid package, usually charged for on a monthly basis. The new model is you sell inside of an ecosystem. So you're monetizing the end user's data indirectly, and you're selling them a variety of digital ads. Could be cloud services like data storage, financial services, things like Apple Card, for example. There's data for enterprises, so reselling data to enterprises so they can make more informed business decisions. There's media and entertainment, e-commerce. There's others as well, but these are some of the primary ways that hyperscalers make their money. Give away the access to the user, the network access, and you monetize them indirectly inside of this ecosystem. It's dynamic, it's usually autonomous in how the mechanisms are here. And this is lucrative, and it's a scale game. So the more time in ecosystem and the more connectivity an end user has, the more profit and revenue growth the hyperscalers get. So we're going to talk about Reliance Jio because they're doing a really good job demonstrating that a traditional telco can still be relevant in this market shift. In India, there were 13 operators in 2016, and the list of them is there. After Reliance Jio disrupted the market, there's 4 left. There has been transformational disruption in India in the span of 4 years. And the telecom industry looks completely different than it did 4 years ago. And it's because of this one operator that came in with a hyperscaler model, and they completely disrupted the entire market. And just the speed with which they did this is unprecedented in the telecom industry. Scaling from 0 subs in September of 2016 to over 400 million subscribers in the span of a few years' time is unprecedented for any operator. And it is worth looking closely at how this actually happened. So what Reliance Jio did is, first of all, they used a completely new network architecture for their LTE network. It's a greenfield build. So that gave them an advantage over the brownfield operators. The second thing they did is they brought low-cost smartphones into the market, also called the Jio phone. So they got smartphones out and widely available so they could use that as a data gateway into their ecosystem. And then they gave away connectivity for free. They ultimately changed that model after they reached a certain maturity level, but they're still charging prices that are much less than what was traditionally charged in India for data, voice, and text service. And the intention is Reliance Jio Platforms, which is a subsidiary of that conglomerate, they're going to use a variety of digital businesses that they've built, spanning e-commerce, fintech, digital ads, et cetera, to monetize the subscribers in that ecosystem in different ways indirectly, and they're going to scale that out, and they're going to drive revenue, profitable revenue growth in that manner. Now, the incumbent telcos could not compete with that, and many of them either went bankrupt or they had to merge. Some of them are barely hanging on, the ones that are still around. And this situation is very pertinent for what I think we're going to see happen in other markets because the disruption is so significant. We're going to see what happened there. Might look different, but the similarities are going to be striking, how this is going to look. I want to talk about Google now and Google Fiber. Google Fiber is still around, and Google Fiber is building again. They started building the network again. They're building now in Colorado, Arizona, and a couple of states that they previously were in. So they're still moving forward with this, and there's a reason for that. This business model is too lucrative to ignore, and they're approaching this through FTTP, FWA through WebPass, and they're also looking at partnership models to scale out this business model that they are bringing into the market. If we look at Google Fiber, which has been around since 2010, that program is very popular with governments and consumers for bringing low-cost, high-speed internet to their towns and cities. The fiber program has pushed incumbent ISPs in recipient markets to reduce their prices and to increase broadband infrastructure investment to compete. Part of the reason Google's able to give away the fiber access at cost, essentially they're breaking even on the access, is because they're monetizing indirectly those end users. If you give away higher speed service and a better QoS on the connectivity side, you can extract more value that's coming over that pipe to those end users. That's the business model, and that is justifying the money they're spending on that infrastructure. That program made 1 gigabit per second the gold standard for high-speed internet in the States. That's the threshold now that is table stakes, and that's where all the fixed guys are trying to get to. Again, I want to reiterate here, they're essentially giving away that connectivity at cost. The money is that the profitable revenue is coming indirectly from the digital businesses that they're monetizing over that pipe, that they're enabling and driving that data flywheel in a much more efficient and scalable way by providing their own network stack to those end users. All right, that's it for the content. There's a lot more information in the full reports. The folks on the call that are subscribers, I highly recommend taking a look at those reports. You can access them through the TBR portal at your respective companies. And with that, we're going to open it up for Q&A. So I'm going to go right down the list here. There are a bunch of questions, and we'll try to get through as many as we can until the top of the hour. The first question is, will there be pushback against hyperscalers' dominance, especially in Europe? Will it slow down and prevent the market shift? It's definitely slowing it down. And Europe is isolating itself. This is problematic because they're getting left behind in technological development. And unfortunately and fortunately, they kind of need the hyperscalers to drive digital transformation of the continent of Europe. The cloud is foundational and the connectivity is foundational, and neither of those things is adequately provided in Europe today without the hyperscalers. And on the network side, the vast majority of telcos in Europe are not deploying 5G SA, nor do they have intentions of deploying 5G SA until they see clear ROI, which makes sense, but they're being disrupted. So there's a lot of competitive dynamics that need to be considered there for infrastructure development. Europe's in a really tough spot, and that's not even considering the energy crisis they have. It takes a lot of energy to run the cloud and to run networks, and the other issues that they're facing as well. Are the hyperscalers going to remain slowed down there? I think so. I think Europe's ultimately going to have to make some really hard decisions about are they going to stay isolated or are they going to try and catch up And if they try and catch up, they're going to have to align themselves in some way with the hyperscale companies. The next question is, did Reliance Jio run into regulatory fees, taxes, or other obstacles when it challenged the status quo? So they do have to play by, they are regulated by the India telecom regulators, just like the others. Some of that has some of that was not seamless. It wasn't smooth. And I think there's been some fines and things that have occurred to kind of normalize the competitive environment. But yeah, I mean, when you think about the change in the business model and the sensitivity of data, there is obviously going to be regulatory scrutiny in that. And the regulators don't have the answers yet. Everybody's trying to figure out how do we best do this without stifling economic development. And that's a really tough balancing act that nobody has a clear answer for. And there's going to be checks and balances imposed as the industry navigates towards that. The next question is, Apple's autonomous car is assumed to rely on 5G, unlike Tesla. So if you look at so Tesla, I believe, is interfacing directly with Starlink. There's going to be a direct connection there between the car and the satellite network for the connected car. Ultimately, the car is going to have to participate in a distributed computing framework. So it's going to have to ping towers. It's going to have to ping terrestrial assets, essentially, and space-based assets to fully give that car full autonomy, like level 5 autonomy, right? We're not there yet, but it's theoretical. It's conceivable that 5G would need to be used for that because LTE won't cut it and satellites alone won't cut it. It's going to have to be a mix of satellite and terrestrial interfacing with the vehicle in real time to enable that type of a use case to play out, like a fully connected car where the person just gets into it and the car takes care of everything. That level is going to require that type of a network. So yeah, I think 5G is going to be front and center, part of that infrastructure back end that's supporting that. And yeah, I would have to assume that Apple, Tesla, any other car maker that is doing this, trying to build an autonomous car would have to use 5G in some way for that. The next question is there a hyperscaler telecom merger in the future in whole or part? Maybe. I don't, actually, yeah, I do think that will ultimately happen. But I want to be very clear about this. Any brownfield telco that has technical debt with legacy technology is not going to be touched. There's too many problems associated with that. The hyperscalers are looking for next generation, new architecture assets, and they're looking for talent pools that are easy to assimilate into the hyperscalers culture. So if those situations are out there, and there are some, I think that there is a case to be made where it would make sense for them to buy those entities. Those entities tend to be very small scale. The tier 1 telcos, tier 2s, the vast majority of those companies have significant brownfield and technical debt and other challenges that the hyperscalers are simply not going to want to touch that. So it's going to be highly selective, and it's going to be next generation. If you look at Microsoft, they bought Affirmed and Metaswitch. Both of those entities are what I would consider next generation network solution providers. One for the mobile core, one for the IMS. And they bought those entities instead of other types of entities that play in that market. I think that's an example aligning with the comments I'm making. The next question is, what are the specific areas to play for large telco in this game? Hang on one sec, this is a long question. So the question is, what specific area to play in for large telcos in this game? Are they going to provide hyperscalers with connectivity, make alliances with the cloud partners, manage multi-cloud connectivity and orchestration value for customers, or anything else? It's going to be all of the above. The hyperscalers and telcos have a frenemy relationship. I don't see that changing. If anything, it's going to get much more. The telcos are going to have to work much more closely with hyperscalers. They kind of don't have a choice. If you think about digital transformation of the enterprise and where that's happening, it's happening inside of the cloud, and it's happening inside of hyperscalers' ecosystem. So for telcos to participate in that value chain, they automatically have to participate in the hyperscaler ecosystem in some way. So there's going to be alliances, there's going to be provisioning of connectivity, there's going to be co-location, there's going to be maybe some revenue sharing models that we'll see. There's also going to be direct competition, though. So it's very much a frenemy relationship that's going to be the going forward dynamic. The next question is, how do you see traditional nets play in the hyperscale dominant business model? So the OEM situation is challenged, and OEMs are being completely disrupted. I could have done a different slide deck. Instead of looking at the telecom operator business model, I could have put up the OEM business model versus how the infrastructure is changing in the new architecture and how the OEMs are competing against ODMs and software platforms provided by other entities, including but not limited to the hyperscalers. So the disruption is significant. It's mostly on the hardware side, but if we think about legacy application platforms like OSS, BSS, and how those are also going to fundamentally transform in this industry, it's going to affect the software side and the services side as well. So there's multiple degrees, multiple dimensions of disruption that the OEMs face, and it's going to be a challenge to make this shift. That's not to say that some of the OEMs won't make the shift. As we saw with Reliance Jio, there is hope for companies to evolve and to play a key role in the transformed industry, but it's going to be really hard path to actually getting there. Okay, I think that was the last question. So if there's any others, just add them to the Q&A box and we'll get right through it. All right, Haley, I don't see any more questions, so I think we can close out.
Awesome. Thank you all for your questions, and thank you, Chris. If anybody has any additional questions after the event, feel free to email them directly to Chris or to webinars@tbri.com. So feel free to reach out with any follow-up questions. If you have a few moments, it would be super appreciated if you could fill out the survey that's going to pop up on your screen. And a reminder for everybody, a replay version of the webcast will be available after the event and will be sent out to all of you via email. To view a list of our upcoming and past webinars, please visit tbri.com. And be sure to join us on Thursday, October 27th for Trends in Services to Drive Revenue for IT Infrastructure Providers. Thank you all and have a great rest of your day.